I feel as though there are these wonderful secrets, essentially, that are sort of completely invisible to almost everybody in the world who are not mathematicians. Uh, and it doesn't make sense to me that we would want to keep them to ourselves. It's sort of, honestly, I feel as though I've got this really good bit of gossip.
Hello, and welcome to Voices of Mathematics, the podcast from the Maths faculty at the University of Cambridge. I'm Rachel Thomas.
And I'm Marianne Freiberger, and we're from the Communications and Outreach team here.
Marianne, you're just about to interview our colleague Hannah Fry, who has won one of the prizes at this year's International Congress of Mathematicians, which we're going to head off to in a couple of days.
Yeah, she's been awarded the Leelavati Prize, which is awarded for outstanding contributions for increasing public awareness of mathematics. And Hannah has been awarded it for, and I quote from the citation, for having become a voice for mathematics that resonates far beyond the public audience normally interested in science communication.
And we've definitely seen that in action, both through the chances we've had to work with her and seeing her work with lots of different types of people here at Cambridge and her wider work on as a broadcaster. Marianne, I'm really looking forward to hearing your conversation.
First of all, how do you feel about having been awarded the Leelavati Prize?
Uh, it was a complete shock when it came through. Um, it feels as though there is no higher organization, for as a mathematician to be recognized. This is the ultimate, I think. So yeah.
So, as a mathematician, what do you enjoy about communicating maths rather than doing it, like as opposed to doing it or
Yeah.
alongside doing it?
Honestly, I feel as though I feel I think the two things are connected, right? I think that when you enjoy it yourself, I think that you have first-hand experience of just the absolute joy of it, right? The twists and turns that you find, the like the big reveals, the frustration, the exhilaration. I think all of the sort of really clever, strange bits that end up fitting together, just this completely original way to see the world. And I think that in the same way as with anything in life where you really enjoy it, I just want to talk to people about it. I feel as though there are these wonderful secrets, essentially, that are sort of completely invisible to almost everybody. Um, to almost everybody in the world who are not mathematicians. Uh, and it doesn't make sense to me that we would want to keep them to ourselves. It's sort of, honestly, I feel as though I've got this really good bit of gossip, really amazing bit of gossip that I just want to share. That's
Mm,
that's that's how it feels and why I want to do it.
mm. So that because I watched the video that they have
Mm,
made, Simon's Foundation they have
mm,
made for you for your
mm,
prize, where you say that kind of the limitation isn't in people's ability to understand
mm.
maths, but what is important is that you need to get them to care about
Yeah,
it. So,
yeah.
and then obviously that is, when you're talking about applied mathematics, then you can make people care through the application. When
Mm,
it comes to pure mathematics, I mean, what you just said already kind of hints as how why people should care because there is a beauty in it. Is that
mm.
what you think could be used to make people passionate about it, even if it's a very abstract and pure thing?
I don't know if it is actually. I don't know if beauty alone is enough reason because I think that actually, I mean, I do think that really, really amazing pure mathematics is sort of parallel to art in a lot of ways. I think that there's an aesthetic quality to it that can be really mesmerizing. But I do think that actually the beauty alone is difficult because I think that you have to often get people to such an extraordinary level before they can actually really appreciate it. So I think that and then you're I think that at that point you're then sort of struggling with like people having buy-in. Like why would a sort of a person off the street, a kind of random person, want to sort of sit for like 30 minutes while you do the preamble before you get to the beautiful bit? Sort of like you need the promise of a payoff. I think we all do. I think we all need the promise of a payoff. But at the same time, I think I think that pure mathematics has all of these really strange, like extraordinary, amazing ideas in it that get you to that moment much quicker. So I'm just thinking of an example. There's a video that Oxford Mathematics did, they put online, and I'm so jealous of it because it's just really, and it's just a lecture, right? It's nothing fancy. Nobody's like sort of, there's no like animations or anything. It's just somebody giving a lecture. And they have a little round piece of card and a piece of paper with a hole in it. And they show how there's nothing you can do to get this piece of card through the paper. It just doesn't work, right? They don't fit. And then he demonstrates how if you fold it in a very particular way, actually you can slide it through. And this video, Marianne, has got like, I don't know, just untop like millions and millions and millions of people are like amazed and enthralled by it. And what it's doing, I mean, it is like this mathematical idea, right, about topology. But what they're doing in it is they're saying, here is something that can't be done, and really quickly communicating, here is something that can't be done. And now let me tell you why your expectation and your intuition is incorrect. And that's what it's managed to do. It's almost like the way I like to think of it is as though, let's say you lose a tooth, right? If you can remember back to being a kid when you lost your baby teeth, if you've got like a hole in your mouth, right, your tongue is continually prodding at it. It can't leave it alone. And I think what you need to do is you need to create a hole in people's imagination that they sort of know the right size and shape for, right? It's like it's not just a general, oh, let me tell you about 16th century French poetry, right? I don't know anything about 16th century French poetry, and honestly, I probably never will. But if I can create just a moment where you want to know the next bit. You know exactly what size and shape it needs to be to fulfill your craving for that exact piece of information. Then everybody's in. Everybody is in. And I still think you can do that with pure mathematics. I think sometimes it's harder, but I still think that you can.
Do you think this is something that this kind of craving
Mm,
and also the like in your video you also said that once you start looking for patterns you can't stop, you just see them
mm,
everywhere. So do you think this is something that could be instilled in people through a cultural shift almost,
mm.
that we could live in a world where you also talk about if people thought of music as just somebody hammering away at piano keys, then you're missing, you're not seeing that
Of
it's
course.
what is the point of music. So do you think that we could live in a world where that mathematical appreciation could be more commonplace and more kind of like instilled in everyone?
Yeah, I mean, I definitely think that. I do think that I think we do have a really big cultural problem with mathematics, and I think that the culture here is that, I mean, broadly actually with all academic pursuits, but I think mathematics suffers more than most. Um, I think that in the UK and actually, I mean, across Europe and America in general, but I think that we sort of believe that it's either something that you have or you don't have. That you are naturally gifted, and therefore it comes easier to you. Um, and there are places around the world, in South Korea, in Singapore, where I've gone in to visit schools, in China too, I think, where they just don't have that attitude. They don't see it as, oh, okay, well, I either get this or they don't, or I don't. It's more like, okay, well, of course you have to work at it because of course it's difficult. And of course you're not going to see the appreciation of this until you've put in the legwork. I mean, there's this really amazing experiment where they had students from around the world, and they give them a maths question. And if the maths question is really easy, then people from the Western world want to do the next one. They're given a question and then they're given an option. Do you want to do another one? And if it's really easy, then the students are like, yeah, I'll do another one, right? But then what they do is they secretly, for another group of students, the first question they give them is actually impossible, right? They've given them an impossible task. And as you would expect, when these students who have been unable to complete this maths question, when they're asked, would you like to do another one? Almost across the board, they're like, no, thanks, I'm done. Don't want to do it. They do that same experiment, right? The exact same setup, but they do it with students from Asia. I can't remember which country it was, but it was one of the sort of Singapore or South Korea or China. And they do the exact same thing. Easy question. Do you want to do another one? Yes, please. Hard question, impossible question. The number of kids who then want to do another one doesn't go down, it goes up.
Amazing.
More students want to do more maths, the more impossible it is. And the thing is that it's because their underlying attitude is, I just need to try harder at it. I'm not getting it because actually it's a question of effort. It's not that I've been defeated and I don't belong here and that this isn't for me. It's that the students are seeing that and being like, okay, other people can get this, and therefore I just need to put in more.
Mm.
And I think this is it, right? That I think is like the giant cultural difference between us and elsewhere. And I think that extends then to this. I think that as a result of that, I think people have this like genuine like trauma from maths at school, from everything that they couldn't do. And I think that whenever they see something labeled as maths, I think that they just recoil in horror from it. And I think that, I have to tell you, Marianne, like I do an awful lot of maths communication, but I almost never use the word maths, like deliberately, intentionally. I almost never use the word maths because I think that if like people know that I'm a mathematician, and I think when they think about it, they know that I'm telling them maths. But if you start off and you say, okay, everybody, maths is fun, right? Which I know that some that's sort of an approach that some people do. The problem is that then you're telling, not showing, right? And if you cannot in one sentence undo an entire lifetime, an entire culture that is like working against you, I think that you have to like create the missing tooth feeling
Yes.
and then offer to fill it and then afterwards be like, guys, hello, that's what this subject is all about.
Yes. Mathematics by stealth almost.
It completely by stealth, completely by stealth.
Interesting. And what do you think? So, like looking at the other side of it, looking inwards towards the mathematical community. So, this prize that you got, the Leelavati Prize, I think it was established in 2010 at the ICM in 2010. So,
Yeah.
that's not a very long time
No,
ago.
it's
So,
not.
how do you feel? What do you feel is the attitude amongst mathematicians these days towards communication?
um well, I mean, I think that it demonstrates quite a strong um positive step that Cambridge appointed me as their first professor of public understanding of mathematics. I think that's really indicative of the direction that things are moving in. Um, I think, you know what? I do think the world is different than it used to be. I like even when I started dabbling with this stuff, just a tiny bit, which was back in, 2010-ish, when I finished my PhD. I think that there was quite a lot of snobbiness about it still. It was like I had this professor who actually taught me as an undergrad, and he said, "The world fears mathematicians, Hannah. Let's keep it that way."
Oh no.
But I also think all of this is connected, like at the moment we're talking so much about mathematics departments closing down, right, around the country. About funding in general for pure mathematical ideas is extremely difficult. Um, I mean, for mathematical ideas in general, it's extremely difficult, but pure mathematics in particular. And I think all of this is connected. And maybe this is just my own little fantasy that I'm living in, but I really think that if people appreciate a subject. I think all of this stems from appreciation and really understanding what it means to have a mathematically literate society and what value that adds for everybody, not just the people who are doing it. I'm not necessarily talking about like in terms of GDP, but I mean like cultural value too. Um, I really fear for these university closings, not because it's going to, I mean, I think that there's certain levels of, at Cambridge, our research project is like, our research output is really, amazing. And there's still mathematics being done in this country, right? But what I worry about is that the best teachers, right, that you get in schools, they're not the ones who go to Cambridge as an undergrad. They're not the ones who go to UCL, right? The best teachers are the ones who understand what it feels like to not be a gold winning Olympiad, right? At the Olympiad. I think the best teachers are the ones who are like, this really doesn't make sense. Let me break it down in a way that makes it make sense to me and that I can explain it to others. They're the ones who are going to like the ones who absolutely adore mathematics, like really love it, and also understand that not everybody gets it straight away. And I think the long-term implications of this stuff is like, I don't think people are thinking through what it means for mathematics in general, across the board, as a cultural institution, when you are just closing down the ones that aren't, getting crazy levels on the ref or whatever it is.
Mm.
And I do think that all of this comes from the same place. It all comes from the same place, that you have to appreciate this subject and what this subject is doing, and just the like phenomenal difference that it makes across the board before any of this stuff. You can't persuade, members of parliament or whatever to like care about this stuff retrospectively. It has to be like they have to feel it in their bones, right? They have to like it has to run through their blood, Like I really mean that. And I don't think we can fix this in one generation, by the way. But I want to leave the earth having just like moved the dial a tiny bit.
And what about collaboration? Because what you just mentioned, for example, the Olympiad, right? I mean, this is one of the maths Olympiad where you just imagine that there's lots of incredibly gifted maths
Mm,
students winning prizes. But then when I interview the people, for example, who've won the Fields medals now, who've won other prizes, one thing that often, most of the time comes up is that they say, it wasn't me alone, like, and it isn't a subject where somebody sits in a room by themselves and excels and is an absolute genius.
mm,
But
mm.
it is so much about collaboration and about, some of those people don't want to be singled out as somebody who's won that amazing prize. And is that something that mathematics could benefit from if that was more known, or if mathematics was pursued in a more collaborative way, maybe at school, do you think?
Yeah, I mean, look, I'm all for collaboration. Like my entire life is collaboration, right?
Mm.
Like, I don't do anything on my own at all. Even like the silly little videos that I do on social media, I have somebody who works with me, um, who like edits them and to like bounce ideas around off and everything. Um, yeah, I mean, of course, I totally agree. It's coming back to what I was saying before, right? That just the whole image of the subject is completely wrong. I can't think of anything else. Maybe I'm wrong here. Maybe it's my own biases again, but like I can't think of another subject which is where there's such a gigantic difference between what people imagine it is and what it actually is. I just it's crazy to me. This is one of the reasons why, being at Cambridge was such a positive, delightful surprise to me, because I think Cambridge is like built around collaboration. Even the buildings are structured around the idea of collaboration. The college system, which is frankly completely bonkers, and you would never ever design something like that ever. But it like it continues to exist and continues to be successful because of collaboration. And like this is the thing, I just it comes down to people, right? It always comes back to people. Yeah, really does. And I couldn't agree more with you that that collaboration is absolutely central to
Mm.
everything.
And I wanted to ask you, so you mentioned you were appointed as Cambridge's first professor for the public understanding of maths. Was it
Mm.
last year or the year
Yeah,
before?
last
Last year, yeah. And I remember interviewing you then and asked you what was your favorite mathematical moment. And you mentioned something where I think you'd been stuck on some code.
year.
And then
Okay.
all of a sudden it came to you. I mean, we'll put the link to that podcast in the show notes.
Yeah.
Like all of a sudden it came to you and then, it fitted together. So I was wondering, do you have a similar favorite moment from the communication of maths?
Oh, yes, I do. Straight away, I do.
Oh, right. What is it?
Yes, I do. Okay, so in the Christmas lectures, which I did, the Royal Institution's been doing them since, I don't know, 17, whatever, right? Like a long time. And I got to do them in 2019. Um, I was one of the youngest people to have ever done it, by the way. Like, because I was still in my 30s. I think I was like 36 when I did them. And one of the first women, shockingly, it was like all men up until very late. And also, I think only the third time that a mathematician had done it. So it was like it felt really special. Um, yeah, and like this amazing honor to do it. Uh, but what I really wanted to do, I really wanted to do something to demonstrate how counterintuitive Bayes' theorem can be. Um, and David Spiegelhalter, of this parish, has done loads of amazing communication on this, particularly around breast cancer. But I wanted to do something that was like really tangible and that just immediately made sense to everybody. And so that idea of like finding the tooth, I don't know if this, I'm going to call it that from now on, by the way. But this idea of finding the tooth, it was like, okay, how do you make people care? So I came up with this idea that I would have a bag of wrapped presents, and in the in these there are 100 presents in total, right? So we wheel them out in this trolley, and they're all wrapped, right? It looks really cool. And I tell people that there's 5 new phones in there, and the rest are satsumas or socks. But luckily, to help them find a phone, I get someone down from the audience, like, right, we're going to help you find a phone. And then I introduce a present scanning machine, which is basically Matt Parker and a person in a box. It was very funny. But then we run through with Matt's comedy genius, right? Like really he made the whole thing so funny. He's sort of playing this, very kind of lovable buffoon, right? Where he's really proud of this machine that he's made that's 80% accurate, right? It's 80% accurate at finding phones and finding not phones, right? So we kind of go through this process. We're like pushing these presents through this machine. Um, and it will sort of wrap them if it thinks it's in a different way if it thinks it's phone. It's basically someone literally hiding in a box, chucking presents. We're chucking presents at them, and they're chucking presents out. But anyway, the thing is, we kind of go through it, and every kid in the audience is like, "Which one's a phone?" Like straight away, like they're so motivated to care, and then you kind of carry on going, and it's like, "Great, we're going to find the phones. Let's do this." And then you sort of look at the presents as they come out of the machine, and something doesn't add up. It doesn't make any sense at all. That it's not only 5 phones that are there that wrap. This machine is 80% accurate. Surely it should do it. And that's the point where we're like, hang on a second, something's going on. Matt, you've messed up. Like this has got to be wrong. It's sort of like the back and forth of it. Um, anyway, it just worked so well. It took me so long. Honestly, it took me like I think 3 full days to write it. Went through so many drafts to get it right, and then rehearsing it, we just tried it over and over and over again. And the end result is honestly the best explanation of Bayes' theorem I've ever done, and I still feel really really proud about it. But it also it's like it just I think it just really demonstrates that idea that I'm saying here, because if I just put up the equation on the board and told people about it, no one would care. No one would remember it. It wouldn't make any difference whatsoever. Even if I'd worked through an example, okay, here you go, guys. Here are, I don't know, whatever, 10 people some of them are wearing badges or whatever it is, right? People wouldn't care. They wouldn't care. Like, you've got to make people care, and you've got to make it so that the maths feels like the key that unlocks that part of the story that you're desperate to find out about. Like, that is how you have to do it. And yeah, I'm just really, really proud of that.
So that was Hannah Fry, who is Professor for Public Understanding of Mathematics at the University of Cambridge, talking to me 3 days before the beginning of the International Congress of Mathematicians and the announcement of her prize.
So when you're hearing this, we'll be there in Philadelphia, and Hannah will have received her prize. And we're looking forward to reporting on all the prize winners and also talking to the Cambridge mathematicians attending the Congress. Marianne, I guess I'll see you at the airport.
See you at the airport.
Thanks for listening, and bye for now.
Bye.